Hey everyone, welcome back to another video by Camroom 5. In this video we're going to be continuing the concept of ion polarization, and we will try our best to relate this concept to group to compound stability. Remember last time when we were talking about ion polarization, we said that ion polarization is done by the cation, and when it attracts the electron cloud of the anion, it tries to distort it. If the cation is successful, like magnesium for example, the anion electron cloud will no more be spherical and it will become distorted. But if the cation is not pretty successful, like strontium or barium, the anion electron cloud remains normal as spherical and it won't distort much. We said that when ion polarization happens, because the cation had good polarizing power, then as a result a covalent character is developed between the cation and anion, and this results in less stability. And we said when there is no polarization, for example if the cation is unsuccessful like strontium, then the compound remains pretty ionic, no more covalent character, and it remains stable. We will relate this idea to group to carbonates. We have literally the same carbonate in all scenarios, so I'm drawing it like this, that we have the same carbonate. Let's draw it as carbonate CO3. So basically this is my carbonate ion, which has a charge of -2. Since we have the same carbonate, I am making 4 copies of the same carbonate ion like this. But we need to understand that the cation will be changing each time. So this is my carbonate, but this is my cation number 1, cation number 2 which is calcium, cation number 3 which is strontium, and cation number 4 which is barium. So this is magnesium cation, this is calcium cation, strontium cation, and barium cation. We need to understand that out of this first, second, third, and fourth example, magnesium has the highest polarizing power. So magnesium has highest polarizing power, and due to this polarizing power it distorts the electron cloud strongly. But when we talk about barium, it has the weakest polarizing power, So what actually happens is that magnesium becomes very successful at distorting the electron cloud of carbonate. So the carbonate stays no more spherical, but it rather becomes something like this. And this electron cloud density, let me draw it even more clearly, it becomes like this. And what happens as a result of this distortion is that it's easier to break the carbon-oxygen bond within the carbonate. Because of the effect of magnesium, it's easier to weaken the carbon-oxygen bond. Let me show it like this. It's easier to break this bond. So because of the ion polarization, it's easier to break this carbon-oxygen bond within carbonate, because the electron cloud density is distorted. But in case of barium, nothing happens. So barium was a very weak polarizing cation, and it was unable to do anything literally to the carbonate. So the carbonate bonds within the carbonate, the carbon-oxygen bond within the carbonate, are still literally the same. So here in barium carbonate, no distortion happens, no ion polarization happens, and as a result magnesium oxide is less thermally stable because of the ion polarization, but barium carbonate is more thermally stable. It's more thermally stable. So when we compare our magnesium carbonate, calcium carbonate, strontium carbonate and barium carbonate, the most easily decomposable is magnesium carbonate. It breaks down really easily. It is very easy process to break the carbonate ion, make carbon dioxide. It's very difficult in the case of barium because no ion polarization. Let me complete the equation for the other two also. Calcium oxide and strontium oxide are the other two products, and carbon dioxide happens. The easiest process is in case of magnesium carbonate, and the most difficult one is in the case of barium carbonate. We know the reason. Because magnesium got more polarizing power, barium does not have more polarizing power. When we talk about enthalpy of this reaction, the value for magnesium carbonate decomposition is 117 kJ. It's difficult for calcium carbonate, so 176. It's more difficult for strontium carbonate, and it's very difficult for barium carbonate. All these are positive values. So in case of barium carbonate, it's the most endothermic, which means it will absorb most heat. It needs most heat. But in case of magnesium, it is less endothermic, which means it can happen even with less heat. The same phenomena can be applied to the nitrates also, that when we talk about magnesium nitrate, it is easily decomposable, but barium nitrate is not decomposable. So in today's video, we did not do much. We just talked about the concept of ion polarization. Then we talked about group 2 carbonates. And then we said that smaller cation has more polarizing power, so it distorts the electron cloud of carbonate. And then we said it's easy to break the bond between carbon-oxygen within the carbonate ion due to the polarizing power of magnesium. But when barium is there, it has no polarizing power, so it can't break the bond of carbon-oxygen within carbonate. And then we talked about the result of it, which is that barium carbonate is more stable, but magnesium carbonate is not. And same applies to nitrates. I hope this idea is clear to you guys. Stay tuned. Thanks.